All right, good afternoon. This is Jim Kuiper from Argonne National Laboratory, and today I'll be talking about the Energy Zones Mapping Tool. Really one of the core capabilities of the tool is planning a potential energy zone. So this is going to be kind of a classic use of the tool, and it should touch upon quite a few different functionalities. I just want to emphasize, please feel free to ask questions if you have any at any time. The phones are muted, and as long as we don't have trouble with background music or noise, then I'll just leave the phones open the whole time. Or you can use the chat window if you'd like to ask a question that way. So I only have a few background slides here that we normally start with. The mapping tool was developed for the Eastern Interconnection States Planning Council. So that's a group that is focused on the Eastern Interconnection. So in that graphic, that would be the dark blue area in the east. Includes some Canadian provinces as well. And it's the electrical grid that comprises that whole area. 3 national laboratories participated, including Argonne, Oak Ridge National Laboratory, and the National Renewable Energy Laboratory. It was a great partnership, and we really benefited from the subject matter expertise in the other labs, as well as data sets that each lab has developed, and it was a good collaboration. So ICEPIC is primarily comprised of public utility commissions, governor's offices, state energy offices, and other government agencies, primarily concerned with planning energy and monitoring and managing it in the states. There's another similar organization called EIPC, and they are comprised more of the grid operators. And one of their major activities is modeling some of the potential characteristics of the future grid as it gets updated. So the 4 primary things in the Energy Zones Mapping Tool are data, models, reports, and policy information. So I'll be concentrating on the first 3 today, but you should know that there's a pretty extensive policy database that you can get right at the home page. There's policies and regs item on the top toolbar. It's pretty easy to find, and there's over 2,400 policies in the database. The scope of the tool, bottom right, concentrates on clean energy resource categories. Those are all low or no carbon energy resources that are used for power generation. And some of the categories, such as coal, there are assumptions behind the technologies that are being used. In the case of clean coal, these would be newer designs for power plants that include carbon sequestration and storage. And then nuclear as a no-carbon source. So from the standpoint of carbon, nuclear is very good for that. So a few of the recent updates in the tool include quite a bit of new layers in the mapping library. Some of these are updated, so we either get notified or we check and we find that newer data are available for these layers. We go ahead and update it in the tool. So we're actively maintaining the data library. And sometimes there are new layers, especially water layers we're adding this year. So the one in the top, in the graphic at the top right is kind of notable. It's a brand new data set, and it was put together by the University of New York. What it represents is the effects of power plant cooling systems on river systems. So these are rivers with, I think, at least 5 million gallons per second of flow. So it concerns the larger flows. And they've modeled river temperatures from 2000 to 2010 on a monthly basis. So if you look at that layer, you can see this graphic, which is 2010, an annual average, but you can look in the data and get monthly temperature values. So it's pretty interesting to look at the transitions over time from power plants. For modeling, we've added a couple new layers for pipelines. So we already had a layer for natural gas pipelines. So if you want to be close or far from a pipeline, you can use that in modeling. And we added these two new categories of pipelines to kind of round out the pipeline layers for modeling. And then Andy Orr, who's also on the webinar, if you have any questions, has been working on the corridor suitability models. We won't touch on those a lot today, but there was a recent webinar about it and recent tools added for corridors. And we've refined those so that they produce more, a good starting point for corridor modeling. Okay, so I put together these two next slides just to set up the discussion about planning a potential energy zone. And I'm going to just touch on these and then come back to them later. So there's a recent news item that North Carolina is just starting to build the first utility scale wind farm in North Carolina is starting construction. And so in choosing an example, I just thought, well, let's make the victim North Carolina State. So all this is hypothetical. I didn't dig real deep in these model designs, but I thought it would be interesting to look at some offshore power generation as well as land-based. So for the offshore model, I'll be combining these two that you see here. The assumption would be we're looking for areas that might be suitable for both these technologies concurrently. And then for land-based, any of these three technologies are ones that I'm suggesting we'd be interested in for this example. So wind turbines, photovoltaic, and to mitigate the variability of the renewable power generation from land-based wind and photovoltaic, I'm suggesting maybe some new natural gas power plants. So basically, the premise of this talk today is that we're looking for areas in North Carolina that are concurrently suitable for these three technologies on land and the ones I mentioned offshore. With that, I'm going to switch over to the tool itself. And here's the home page for the site. So I mentioned the policies database here. If you're new to the site and you haven't used it before, I've already logged in, but you'll see up at the top right there'll be a register link and a login. So obviously if you have an account you would log in. If not, you can register. It's pretty quick and easy. We do need to prove it. They wanted us to validate that it's a valid email address before we had folks register. And once that's done, you can log in and launch the tool. Everything on these web pages except the tool you can access without an account, including the policy database. All right, so I've already launched the tool, and this is pretty close to the way it comes up when you start. It just has a map of the United States, and you've got the eastern interconnection boundary, and not a lot else. So as I mentioned, we'll be talking about North Carolina today, so I'm going to use the toolbar there and zoom in. Incidentally, there's a splash screen that you can turn it off. I have it turned off right now. It looks like this. So you can, I don't have it turned off, I just had already launched the tool. The point is this will appear. If you are new to the tool, you might peruse some of these sections here, and if you click the button there, it'll open up a video. These videos are about just a couple minutes long, and they introduce most of the major features of the tool. We do need to add a new one for corridors. This gets at the corridor functionality that wasn't, that has been in the tool longer. we've added some new capabilities, and we're going to be developing a video for that shortly. There's also hard copy help. If you just go up to this, sorry. If you go on the home page, there's a menu for all these. These are the videos, and then there's a help manual. We think the tool is fairly straightforward, but it does have quite a few different capabilities. So if you get stuck, all those different resources are available. Okay, so first of all, let's talk about North Carolina briefly as a state. And I'm more of a GIS professional, so I don't study energy systems in depth, but we do have a lot of information here that we can peruse. So I'm going to start by looking at power plants. And as I mentioned, the first wind farm in North Carolina is starting construction, at least utility scale. So this layer is from Platts. It's a commercial layer that's licensed for use in the tool. And this shows all the different power plants in North Carolina by their overall type. And these types are the same categories that I mentioned on that slide. So if you wanted to take a look at the energy portfolio for North Carolina, what's the current generation portfolio, you can go to the Analyze button, and if you pick Power Plants in the Report section, you can run a Power Plants report. So I clicked on that action icon, and I'm going to ask for a state, North Carolina, and you can do buffer zones around your area. So just real quickly, you can draw an area on the map. I'll be showing that later. So these reports can be run for any area you designate, and these buffer zones make more sense when you've sketched your own area. So for a state, we pretty much just want to see what's in the state, and we're not worried about what's adjacent to it. So then I click Launch, and that report, there's a little message that comes up in the corner of the screen, and it's already completed. So we look at the results, and what I normally do is sort my results by the date the reports was run. And you see this power plant report. I had run it before the webinar. I just ran it again. So I can open it up by clicking this icon. And that is the general approach that you use when you're running reports. So you pick an area. In this case, I use the state, choose the report, run it, and then look in your results and open up the report when it's finished. So this shows existing generation graphed by the capacity in megawatts, and so primarily natural gas with some coal. You don't see any wind there. There's a little bit of solar, and you can get a sense of the balance in the state. And then for planned, as far as the data are concerned, this is the Platts data. You can see that there's planned capacity of 800 megawatts of wind in North Carolina. So you can do that for any state or region you're interested in, and it just gives a quick assessment of what the current and near-term energy generation capabilities would be. So now this is just a hypothetical example. So oh, and by the way, there is a planned power plant layer, so you can add that to the map and take a look at any of these points. So if you click the Identify tool, you can click on one of these and see that here's a solar project that's planned. It's got information about the company and planned capacity and quite a few other statistics. Okay, so again, the premise of this webinar is that we want to see what region of North Carolina might be suitable if we're going to designate an energy zone or just see an area where we might have all those three capabilities combined. So under Analyze, I can run a model. And that's the top section. We have all these different models you can choose from. And here we have land-based wind turbine. It assumes a 100-meter hub height. The new wind plant is actually installing turbines that are higher than 100 meters. So they're taking advantage of some higher winds. Usually the taller the turbine, the more steady and strong the winds are higher from the surface. So this is the default model for land-based wind turbines. And all these models, all the default models have been run already. If you just want to look at the results, I'll show you how to do that. Or you can inspect these and make adjustments and run it yourself. So, for example, land cover area, we've made some assumptions here. So, land-based, we want to avoid open water, avoid glaciers. That'd be pretty rare anyway in North Carolina. Here we're avoiding higher intensity developed areas. The assumption is we've got a wind farm, not just an individual turbine, and so that wouldn't make much sense for a dense urban area. And we're assuming that we want to generally avoid forests, not prohibit the possibility, but have a lower suitability. And all these other land cover classes have been pre-assigned. All right, so if you inspect and you like all these settings, you might be happy with the default model. If not, you can obviously make all these adjustments, and you can also add layers. Any layer in the modeling library can be added to the model, and you can design your own model. You can also design it completely from scratch if you use this Create New Model button. So what I did for this demo is kind of make a hybrid model, and I combined those three in the slide. Let's take a quick look at that again. Okay, so there's some common layers between these. For example, land cover is in each of the three models. It's weighted differently, but generally the land cover classes are consistent, and things like protected lands and habitat appear in all the models. But obviously the resource that you're using is different. So for wind, we have gross capacity factor for wind turbines. For photovoltaic solar, we're using data from the National Renewable Energy Laboratory for assuming that these are tilted photovoltaic types of panels. And third, a combined cycle natural gas turbine needs a gas source. So its resource isn't renewable, but it's this natural gas pipeline. So what I did is I took the major factors, combined them, and some of the siting factors where they varied, I included them. And going back, it's going to be quicker to, there we go. Okay, so going back, I ran this previously, so I'm just going to show it to you. Here's the power plant model, wind, solar, and combined cycle gas turbine. If I hit the gear icon here, you can see the design I used for that model. So I started with the wind model, took all its layers, then I added these four at the bottom: slope, the solar, the source of natural gas that would be needed if it's a gas turbine, and some cooling water for the natural gas power plant. I could have refined these much more carefully one by one and really considered them. Obviously, you'd want to do that if you're doing a serious study and not just a demonstration. Okay. Now, as I mentioned, the default models have been pre-computed. So if you register as a new user, you'll see all these system models in your results already. And here's utility scale photovoltaic default model. I can just click this green icon and add it to my map. I'm going to add some of the ones that I used here. By the way, if you use this drop-down arrow, you can filter and find things quicker. Here's land-based wind turbine model. What is it? It's combined. What is, I can't think of the DCGT. That's what I was looking for. Here's the combined cycle. So let's start with these models. So right now we're looking at a suitability map for the combined cycle gas turbine. And so one of our siting factors is we want to be close to water, so you're seeing some higher suitability areas near water, okay? And all those other siting factors are coming into play. These black areas are areas that are inappropriate, so they could be a national park, or these look like distance zones, so this would be an area that's quite far from a natural gas pipeline of a sufficient capacity. You can inspect all the different inputs and find out the results. And then here's land-based wind turbines. Here we need to avoid populated areas and airports, so those are some of those speckle. And then thirdly, we have the utility scale photovoltaic. So that one's more uniform. It could be more of a characteristics of the land. Obviously, the solar data doesn't vary as much because the angle is pretty consistent and the cloud cover. So that model doesn't vary as much. So the different colors or different suitability values in this tend to be more of the other siting factors. But we're not really trying to site one of these at a time. We're trying to find a zone that could accommodate all three of these types of power plants. And so let's look at the results of the one that I combined. So here we have the wind, solar, and CGT model. Oh, what happened here? Okay. So let's, by the way, these values are relative. So the scale is 0 to 100, but it really is very highly dependent on the number of input layers and the weights and all the assumptions. So you can't really compare them against each other, but the relative suitability is correct within the model. And I'm going to just add, I'm sorry, while I'm in here. So I did a similar run for offshore for those two, and model result offshore. I'm going to add. That gives a more uniform map. Okay, so now I have some offshore areas. We don't want to be too far from shore, so it kind of adds a belt along there. And this area here in North Carolina is one of the higher suitability areas. You can change the order of layers by dragging and dropping them. And if they're higher up, they draw on top. So here we see North Carolina's border. Okay, so we've got this area of higher suitability, and if we're going to have offshore, we might want to be kind of close to shore. So I'm going to use that as my example. So remember, these are areas that are suitable for all those three technologies at once, onshore and then offshore. So what I did was I added a new analysis area. So this is where we define the zone that we're interested in studying. Let's get this off to the side. I can turn the layer on the map, And you can see there are these two green areas here that I've added. So I've done a lot of the demo in advance. So I'm just I'm showing you the results, but I'm also trying to show you the steps I took in getting there. So if we wanted to add a new analysis area, we hadn't done these previously, wanted to add one, you click this button, and then you sketch on the map. So let's say we want to capture this area of higher suitability. You sketch it, I'm single clicking the mouse, and to finish I double click. And then I'll just put test. Give it a name. If you want to add some notes, there's plenty of room for that. And you can save that. So that's how you add these to the map. I'm just going to delete this one because I've already created the ones for the demo. Okay. Oh, I have a question. What was the operation used to combine the three energy type suitability layers? What I did was I started with the wind turbine model, the offshore model, offshore wind turbine, and then I manually added the other layers. So I took a look at the two other models, and they have a lot of common layers. So I added a solar suitability, and what I did is I combined the resources necessary for the plants, and they have many common suitability factors. So it was somewhat hypothetical, but it's a general approach that'll get you there. Okay. All right, so I already showed one of the reports for the state of North Carolina. While I'm here, let's take a look, just as an aside, at that new wind turbine, because that happens to be in the same area as this higher suitability. Partially coincidental and partially the model results do show a higher area of suitability there. So one layer that's pretty interesting, if you just put in turbine or wind, the FAA has to permit towers, and including wind turbines, and they have a database for that that's very accurate in location, because that's pretty important. So if we add that to the map, and let me turn off these models for a moment. These are areas where wind turbines are being studied, and this, by the way, is completely coincidental that there's some wind turbines that are being contemplated there. If they're green, they're existing or under construction, but these other categories depict locations that are in an earlier stage of FAA permitting. So it's kind of a unique and interesting layer because it shows places that are being studied. Some of these may never be built. And then that red category, well, okay, so it looks like we have a flaw in our region. Those red categories mean the FAA has determined that the permit, there's a hazard in that area. And it could be there's a lot of waterfowl there, or it could be an airfield, or some other feature that would be a problem. So yeah. All right. Let's go back. So the models that I ran got these areas of high suitability. So I can look at any of the layers that went into the model, and I can do that by going to the library and clicking on the model layer catalog and looking at the suitability of each of these. So if we just want to take land use by itself, let's do that. Okay, so we can take a look at the energy zone. Here's the land use categories that are in it, and it looks like a substantial amount of the area is wetlands. Now, I did have some unsuitable areas in my zone, so those would be lower suitability. These red areas would be urban, and then there's not much forest there. Quite a bit of cultivated crops in the area, so that kind of gives me a general sense of the area. So any of those modeling layers can be brought in and looked at. If you want to get a sense of how the model performed in that location, that's where the model result reports come in. So for my land-based area, I use this icon here, run a report, and I can choose the model result report, and then choose which model run I want to study. So here is our onshore model, and I can launch it. Same thing for the offshore. So I've already previously run these, so just to save time here. Okay, so let's see, model result report, land-based. What this does is it combines the model results and the area I'm interested in. So the model was run for the entire IcePick region, but I'm not really interested in the global performance of the model. I want to see how it performed for my energy, my zone that I've designated. So what this is telling me is that overall the model didn't have a high degree of suitability. It was comparatively high for the state. So it's pretty good for the mean is here. We have values in the range from 0 to 100 for population distribution, but on the whole, the site doesn't have a lot of concerns about high density populated areas. And you can go down and see the overall mean for each of the inputs and then the range of values. So notably, the capacity factor isn't that great for wind in this area, but as I mentioned, that wind farm is taking advantage of higher heights than our model has, 150 meters, and they must have done some studies to see the quality of the wind at that height and found it to be economical. So the model result report is a little bit deep in the weeds, but it does tell you quite a bit. Actually, let me open that again. Okay, so here, this is the distribution of suitability for the model combined, and for each of the input layers, you could see the distribution of values. And then at the bottom, all the model input parameters are described, the weights and all the per category weights, and so you do have a documentation of what exactly that model entailed. All right. So, okay, modeling. Now, the reports are used for a whole variety of purposes beyond studying the result of the model. And so I've run a series of reports, and they're all available in that same way. If you go to your model, your analysis area, and then you click that run a report icon, you can choose among any of these other choices. So I've run a whole series of those. And let's just take a look at some of the results. So in the extent column, you can see that I ran a series of them for the land-based area and then a few for the offshore. And if we take a look now at the electrical transmission report, this summarizes the electrical transmission in the area, and it looks like there isn't a whole lot of existing transmission. There's one larger substation, and one power line. So we may need to, we may have a constraint for transmission. The tool is really for planning, so part of planning is considering what needs to happen in the future in terms of transmission. So if you have a region that you think is worth developing or has a lot of potential, part of that planning might include adding transmission to it. You can run the models with the assumption that you want to site your energy projects near transmission, or you can delete the transmission constraint and assume that part of the planning will be to add transmission to access the region. Okay, another angle on it is the EPA has a series of brownfield sites. These are locations that have had some sort of industrial plant or something maybe with some contamination, and some of these are actually encouraged for development of power plants. So it's a new industrial use, maybe not residential or a park, but could be a good place for a power plant. Normally this report has a ton of results. It appears that there are no brownfields in the extent that I chose there for this analysis area. Other regions would have quite a few different brownfield sites, and you might find that if you want a power plant of a certain category and type, if you look into that, there might be some special incentives for developing power plants on those brownfield sites. All right. What about protected lands? It's a completely different angle. It was included in the model, but what are the exact details? So it looks like we have very few issues in that analysis area. And so there's one layer called the Protected Areas Database, and it looks like we have Northwest River Marsh State Game Land and Dismal Swamp State Natural Area. That's pretty highly protected. That's why it's orange. And then these are the other distances that I mentioned earlier. But the column within my analysis area is here. If I scroll down, there's also this Marine Protected Areas Database, and it's part of the River Marsh Game Land again. Must have some water areas. There's also a scenic byway that's within 5 miles, but it's not within my analysis area. So this report taps into a lot of other layers that only appear if they're present in your analysis area. So this isn't the whole story on protected lands. For example, there's a national easement database that gets consulted, and there must not have been any easements in this area for conservation. So the site doesn't look like it has too many issues with protected lands. Let's take a look at habitat. Okay, so we have a little bit more areas that are of concern at some level for habitat. And here we have in a layer called the Eco-Regional Portfolio that was developed by the Nature Conservancy. We've got a Mid-Atlantic Coastal Plain. These are the layers, these are the names of the layers in the tool. So if you want to see that on the map and how it correlates with your area, this report will lead you to the layers that overlap your area and might have potential issues. All right. So another source, Green Infrastructure Network Characterization, has some areas of concern. Great Dismal Swamp is an area that has important bird species in it, and that they are developed by the National Audubon Society. Colorado State has a model for landscape permeability. Has to do with habitat. It's a pretty complex study, but it's worth looking at. You can see there's actually over 70 layers that get checked for this report, and it's a pretty quick screening tool to see what kinds of habitat issues might come up if you do some power plant development in this region. Okay, remember we were interested in natural gas power plants, so I ran a pipeline report. And we did say we wanted to be close to natural gas pipelines in the model. So it looks like there are lines with the unknown diameter in the area that we might need to take a look at. Other than that, it may not be as favorable as it looks. So we really need to double check our pipelines to see if we do have a good natural gas supply in this region. Okay, so just to illustrate that, so pipeline report is based on pipeline data. Those layers are mentioned in the report. If I go back to my library, map layer catalog, I can go to pipelines or put in a search term, and here we've got natural gas existing pipelines. I'm going to put the proposed lines on too, see if there's any new development planned. And these layers, by the way, don't show at larger scales, so you might need to zoom out to see it. So turn that back off. So you can see, here's my analysis area. I may not have a pipeline reaching this area, but I do have some smaller pipelines. So what I'm really doing is working through a variety of different data sources and reports that I can use to learn about my energy zone. Okay, switching gears to the offshore one, let's look at some of those results. And first of all, I have protected land. I guess land would be in quotes there because it does include offshore areas. And there's some land and water in there. So here we've got the Pea Island National Wildlife Refuge. That's pretty bad for sighting. So that's why it's red in this report. And I sketched a pretty rough area, so and then here's the Marine Protected Areas database. There's also marine areas that are part of that. I've got crab spawning sanctuaries and herring management areas. And then in this case, we're in the Outer Banks Scenic Byway. It does cross our area. So those are some concerns. This is shorelines along the ocean are pretty valuable real estate. It's not too surprising if I included these barrier islands that I've got some fairly significant habitat and protected lands concerns. But our technologies, one of them is tidal hydrokinetic, and there was a higher flow area between the barrier islands. That plant, it shouldn't be sited in sensitive habitat, but it may not be highly visible in terms of the scenic byway, whereas offshore wind turbines might need to be sited quite a distance offshore if they aren't going to impact that scenic byway. All right. Let's see. There's a third category, wave energy. The newsletter had an example that Hawaii just put in an experimental power generation using wave energy, and these technologies are being studied. So you can't run a model for this because it really doesn't have the spatial resolution that would make sense, but there is data available for wave energy. So I ran that report for this analysis, this offshore area, and you can see that there's some seasonal variation there. So the blue is the power density. So September would be, and April would probably be the best times of year for generating power with some sort of wave energy system. And it may not be that suitable of an area for that variability. The power plant wouldn't be very useful during the summer months for wave energy. Okay. Then that's kind of a full circle of starting with a model, using it to isolate an area that has a whole set of siting factors co-located, and then studying it further. So for the land-based area, and we found with the wind turbines that there's some sort of hazard that wasn't in the model, but looks like we missed some potential hazard for wind turbines. We found some habitat concerns, and for the offshore we also found habitat and protected lands concerns, and that's where you would get into more of an iterative analysis. You can inspect the layers on the map to see if you want to eliminate some area in your region of study. You can copy and adjust the boundaries of these. Here, I'll show you that. Okay, so I've got this land-based area. If I click this yellow icon and hit copy, I need to keep this open, but I can revise this boundary, and of course I can have some base map layers in the background as I do that to guide me, and then I could save that, and I've created a new area, kind of revised it. The reason why we don't modify the previous one is that if you've run reports, it would get quite confusing to tell whether the report was run before or after the revised area. So each one of these would be a new area, hopefully with a different name that helps you distinguish it. All right, so one of the things we found was pipelines. I'm going to go ahead and get into the corridors a little bit. Let me see. Turn off the base map. See the power lines a little, or the pipelines a little better. Okay, so we've got these natural gas pipelines existing. Okay, so let's say we wanted to find an area, a path for this pipeline, to extend this pipeline to my region. And so we need an energy corridor for that. A simple way of doing it, you can just sketch a new corridor. Let's say I wanted to just, oops, got to turn off my zoom tool for that. Okay, so let's see. Okay, so corridors are blue. I can just sketch that in. Or I can use the new routing tools, and if I go to corridors, I can, first of all, we have these suitability models. So like the power plant models, these suitability models take into account a whole series of siting factors. But in this case, the siting factors are whether an energy corridor would be suitable. And here we have a model that leans more toward pipelines. And if I click this icon, I can see all these different characteristics of it. So it's trying to link to existing natural gas pipelines and follow those routes. So the premise for that would be that we want to add a second line, and we think that using an existing pipeline right-of-way would be good for that. But in this case, well, let's keep that in there because we might want to follow one of the smaller pipelines in the area to supply our new zone. For slope, we don't want steep slopes. We want to avoid certain land cover areas that would be more sensitive, etc. But this model is geared more towards energy corridors rather than a particular type of power plant. So I would run this model just like I would power plants. And corridor modeling is having the system generated is a two-step process. First of all, you create a model that it's essentially a suitability surface. How suitable is each cell for crossing with the corridor? And then we designate the two endpoints that we want to connect. And what the model does is it generates a route between those 2 points that follows the most suitable path. Okay, so I've got a series. I've already created a lot of corridors, so I'm going to create another one. And if I generate from endpoints, we can use the same 2 points that we had originally. So here's a starting and an ending point. And I don't need to double click for points, just 2 clicks for the 2 endpoints. I can give it a name. It's called pipeline corridor. And these are the default models, so I can pick the existing pipeline model, and when I click Save, it launches that corridor. So I didn't wait for my corridor model to run because I knew there was already a default model that I could use as an input. If I wanted to make revisions to the default model, then I would run it myself before I ran my corridor. But the corridor run already finished, and now the model did as well. And so in this case, it designated a much more convoluted route to connect these areas. Why did it do that? That's what the corridor report is for. So let's go back to our corridors. Maybe just sort them by the dates they're together. Here's the hand-drawn one. I'm going to run a report for that. Corridor report, and launch that. And then I'm going to launch a report for the pipeline. Launch. All right. Let's go to the results. Okay, we've got a problem. Okay, for some reason the hand-drawn one didn't finish. Let's look at this one. They both have the same content, so I'm not quite sure. I'll check why that other one didn't finish, but what you could do is have the 2 corridor reports side by side, and you would compare them to see what factors were problematic in that straight line route that I sketched, and then you can see if the automatically generated corridor produced a better result. So in this case, just to show you that the sections don't have any population issues. There are very low population counts along the route. Elevation profiles are given in milepost ranges. If it's a longer pipeline, these ranges are larger, but they're broken up. And then there's a slope. So we don't really have any maximum. Here's a 7% slope. Might need to be looked at for routing to see if there's a way to round that or if it's problematic. We've got a couple major roads, and there's a large river that we would have to cross. Okay, there's a swamp. Well, okay, so we've avoided primarily Great Dismal Swamp, but that's probably the area that it's skirting to avoid. Yeah, so we've got that unknown diameter. Here's that pipeline that we saw earlier. and so that's within the route. Not too much problem for protected lands, and looks like we have the same habitat concerns. So we can run the protected lands and habitat reports for the corridor if we like. A lot of the same things I showed you earlier can be done for corridors, so you could study and see what's happening in it, or you could add the mapping layers. Just because it keeps coming up, I'm going to add the protected areas database. And you can see the straight line route that I created looks probably problematic. And that's the advantage of modeling. Why didn't I get it there? Let's see. Okay, so here we have the great, National Wildlife Refuge. Not something that you're going to cross with the pipeline too quickly. So that really shows pretty good illustration of the difficulty. If you're sketching something on the map, you would have to take many different factors into account, and it might be hard to do that all at once. That's what the models do. But then the route that's generated is a little bit convoluted. It's got these jags in it, partly due to the modeling process. You might want to smooth those out. But you can edit those and revise them and run the quarter report and iteratively figure out what a good route might be for supplying grid connectivity to your energy zone. All right, that pretty much sums up quite a bit of details about setting an energy zone. I'd like to finish on time, but also if anyone has any closing questions, please feel free to speak up, and I'll stay in the line as long as there are any questions that people have. If not, thank you for your participation today.